Earth science is the study of the Earth and its neighbors in space. Some Earth scientists use their knowledge of the Earth to locate and develop energy and mineral resources. Others study the impact of human activity on Earth's environment, and design methods to protect the planet. Some use their knowledge about Earth processes such as volcanoes, earthquakes, and hurricanes to plan communities that will not expose people to these dangerous events. Many different sciences are used to learn about the Earth. However, the four basic areas of Earth science study are geology, meteorology, oceanography, and astronomy. Geology is the primary Earth science. The word means study of the Earth. Geology deals with the composition of Earth materials, Earth structures, and Earth processes. It is also concerned with the organisms of the planet and how the planet has changed over time. Geologists search for fuels and minerals, study natural hazards, and work to protect Earth's environment. Meteorology is the study of the atmosphere and how processes in the atmosphere determine Earth's weather and climate. The study of meteorology is of critical importance in protecting Earth's environment. Oceanography is the study of Earth's oceans, their composition, movement, organisms, and processes. The oceans cover most of our planet and are important resources for food and other commodities. The oceans also have a major influence on the weather, and changes in the oceans can drive or moderate climate change. Oceanographers work to develop the ocean as a resource and protect it from human impact. The goal is to utilize the oceans while minimizing the effects of our actions. Astronomy is the study of the universe. A knowledge of astronomy is essential to understanding the Earth. Astronomers also use a knowledge of Earth materials, processes and history to understand other planets, even those outside of our own solar system.
Our solar system is the region of space which falls within the gravitational influence of our Sun. The solar system is thought to have begun forming about 5 billion years ago from a giant spinning cloud of gas and dust. The core of this cloud grew under the influence of gravity and became denser and hotter. As material fell towards the growing core, the cloud increased in speed and flattened into a giant spinning disk. Eventually, the increasing temperature generated enough energy to trigger nuclear fusion. This fusion marked the birth of our Sun. The lighter gas was swept far out into the solar system, leaving heavier, rockier material and metallics with high melting points nearer the Sun. Molten metal and dust particles stuck together to form clusters, which in turn stuck together to form rocks. Mutual gravity caused these rocks to come together, eventually to form planets. In the hot inner regions of the solar system, rocky planets with metal cores were formed. In the colder outer regions, things were different. Further from the Sun, temperatures dropped. Water vapor condensed and turned to ice. This ice, combined with the vast amounts of gas blown away from the Sun, meant there was a lot more material here than in the inner regions. As huge cores of ice and metal grew, the gases swept away at the sun's birth were attracted through gravity. When the accretion of most of the ice and gas was complete, we were left with the gas giants. The solar system as we know it is around 4.6 billion years old. It's looking pretty good for its age.
Our home planet is the third planet from the Sun, and the only planet we know of so far that's inhabited by living things. While Earth is only the fifth largest planet in the solar system. It is the only world in our solar system with liquid water on the surface. Just slightly larger than nearby Venus. Earth is the biggest of the 4 planets closest to the Sun. All of which are made of rock and metal. The name Earth is at least 1,000 years old. All of the planets, except for Earth, were named after Greek and Roman gods and goddesses. However, the name Earth is a Germanic word, which simply means the ground.
Four spheres of the Earth. The Earth can be divided into 4 major spheres. The names of each of these spheres come from the Greek words that describe what they're made of. Geo for ground, bio for life, hydro for water, and atmo for air. Let's take a look at each of these 4 spheres in a little bit more detail. Up first is the geosphere. Since geo means the ground, the geosphere describes all the rocks, minerals, and other parts of the ground that are found on and also inside the Earth. The geosphere includes the inner core, outer core, crust, and the mantle. So, the geosphere would include the ocean floor, all the rocks on the surface, the sand in the deserts, and inside the Earth. The hydrosphere is made up of all the water on Earth. This includes rivers, lakes, streams, oceans, ice caps, glaciers, and even moisture in the air. If you take a look at the Earth from space, you will notice that it is blue in color. This is because the Earth's surface is over 70% water. Most of this water is found in our ocean. The biosphere is the zone of life on Earth. The biosphere extends to any place that life is found or can exist. This can be in the air, on the surface of the Earth, in our oceans, or any other location. And finally, our atmosphere is the layer of gases surrounding our planet. The atmosphere of the Earth is composed of nitrogen, oxygen, some argon, carbon dioxide, and some other gases in small amounts. These gases are held in place by the pull of gravity.
The crust. This is the outside-most layer of the Earth and is made of solid rock, mostly basalt, and granite. There are 2 types of crust, oceanic and continental. Oceanic crust is denser and thinner and mainly composed of basalt. Continental crust is less dense, thicker, and mainly composed of granite. The mantle. The mantle lies below the crust and is up to 2,900 kilometers thick. It consists of hot, dense, iron and magnesium-rich solid rock. The crust and the upper part of the mantle make up the lithosphere, which is broken into plates, both large and small. The core. The core is the center of the Earth and is made up of 2 parts. The liquid outer core and solid inner core. The outer core is made of nickel, iron, and molten rock. Temperatures here can reach up to 50,000 C. The lithosphere is broken up into separate plates, which include continents and ocean basins. This map shows the locations of the major tectonic plates on the Earth's surface. Note that larger plates include both ocean basins and continents. Plates are made of lithosphere, the Earth's cool, brittle outer rocky shell. There are three types of plate boundaries that exist. Where plates move away from each other, the boundary is divergent. Where they move toward each other, the boundary is convergent. Where they slide past each other, the boundary is a transform boundary. Divergent plate boundaries. Divergent boundaries can be mid-ocean ridges or continental rift valleys. At these boundaries, two neighboring plates move away from each other. Continental rift valleys are characterized by normal faulting and basalt-rich volcanoes. Convergent plate boundaries. Convergent boundaries form where two plates collide. These boundaries often form major mountain chains. These boundaries are identified by their high mountains, volcanic island arc chains, and deep earthquakes. In the diagram above, the ocean lithosphere subducts underneath the continental lithosphere. This results in the destruction of the ocean lithosphere and the formation of magmas, with island arc volcanoes above. The deep ocean trench marks the plate boundary and is where the subduction of the ocean lithosphere begins. Earthquakes can occur in the trench, where they can cause tsunamis, and all along the subduction zone. Transform plate boundaries. Transform boundaries form where two plates slide past each other. These boundaries are characterized by shallow earthquakes. This satellite photograph shows Point Reyes, California, and the San Andreas Fault. Here the Pacific Plate is sliding past the North American Plate.